Okay, if we're going to write something in sigma notation, whoops, I just erased it. If we're going to write a series in sigma notation, you need to have a rule. And then on the outside, you're going to have your sigma. You're going to have something that you start with, like I equals 1, and then you have to have a finishing number. I'm going to call this finishing number. Finish number. Okay, that sounds good. All right, so you guys see the 6, the 12, the 18, and 24? Do you guys see a pattern right there? What's the pattern? It's adding 6 every time. So that means this is arithmetic. So my rule is going to look like this. We have start with 6 plus n minus 1, and then we're going to multiply it by negative 6. How come we start with 6? Because that's the first term. Right? Not negative 6. That's silly. It's positive 6. Why is it positive 6? Because each time we're increasing by 6. Okay, so when we simplify this, we get 6 plus 6n minus 6. Oh, look at that. So this is just going to be 6n. So that's my rule. And so I'm going to take my rule, 6n, and I'm going to go... And I'm going to put that guy right there, and I'm going to go I equals 1. And then where am I going to finish? Which number is going to be the last number that I plug in? 4? Is that right? Yeah. Okay, and then you can test it. You could plug the 1 into the n and see if you get the first term right here. And if you plug in 2, do you get the next term? And if you plug in 3, do you get the next term? Yes, it works. Okay, so that one was simple. That was an arithmetic rule. Sometimes they have geometric rules, like letter D right here. What is happening every single time on this one? How do we go from 125 to 25 and then 25 to 5? So that's, what's my common ratio then? 1/5. And so we're going to take the first term, which is 125, then we're going to multiply it by 1/5, and that's going to be raised to the n minus 1. That is your rule. I wonder if we need to do, we don't need to simplify this more. We can simplify it more, but let's just leave it like that. So I put my sigma out in front of it. I'm going to put I equals 1. I'm always just going to start with I. Actually, dang, because I put an I there, I should change this to an I. So let's use the n. Did I do that on the other one?
No.
I did. This is not supposed to be an n here. It's supposed to be an I, because it has to match this variable. Okay. All right, so this one I'm using n. It doesn't matter. And then what am I going to finish at?
5.
3. Because there's 1, 2, 3. There's 3 terms, so we're going to finish at 3. There you have it. That one is finished. Now I can simplify this a little bit more. I don't know if you guys will like it, but I'm going to do it anyways. We can rewrite 1 over 5 to the n minus 1 like this. 1 over 5 to the n times 1 over 5 raised to the negative 1. Why are we allowed to do that? Because do you guys remember the rules? Whenever you have the same bases and you're multiplying, what do you do with the exponents? You add them together. Okay, so if I did add n and negative 1, I would get n minus 1. So what is this though? What is 1/5 raised to the negative 1? That's a 5. And so I have 5, 1 over 5 raised to the n. Okay, so this is the same as this. And so if I replace this guy with that, if I do some substitution here, it would be 125 times 5 times 1 over 5 raised to the n. What is 125 times 5? 625. So 625 and times 1/5 raised to the n is the same thing. What we just did is created the same rule. It just looks differently. So this is right, and this guy is right. They're both correct.